Hello all and welcome to lecture 3 of this Python programming series. So let's go ahead and get started. Today we're going to talk about chapter 3, and in that I'm going to reference Appendix A in our Think Python book. And feel free to read that section on your own. It has some really good debugging information and tips and tricks. I'm not going to go into that very much in lecture, but definitely take a minute and read it, especially if you're having debugging issues. And then finally, we're going to finish up chapter 7 with our iterations and using the break, and we're going to talk a little bit about what algorithms are. Chapter 3 is all about functions, and a function is a named grouping of statements that does one specific task. We say that we call a function when we use it, so there is a function call that's going to happen somewhere in your program in order to use that function. Functions can have values sent to them, and we call those values arguments. And if a function is going to send back an answer, we call that the return value. So for example, here we have a function int, and it's going to take any string and convert it to an integer number. So here we send int in parentheses with quotes the number 32, and it's going to take that string and actually make it into the integer 32. Some of the most common functions that we're going to use in Python are math functions. Now, a module is a file containing a collection of related functions. So we have a math module that we can use within Python, and we've kind of talked about it a little bit before. In order to use these modules, we have to tell Python to import that file containing the collection. So we'll say import math. Once we do that, we're able to use any of the functions within that module. That import statement is going to create what we call a module object. So it is creating an instance of that module as an object, which allows us to access it and use it. In order to call the functions, we're going to use something called dot notation. Like you can see here, we've got math.sign, and we're sending it radians. That's going to return back what the sign of 0.7 is, and we're going to store it in height. We're going to see the dot notation a lot more as we move on, but just know that if it is a function within a module, we use the dot. We can do something called composition, where we take small blocks of code, and by doing that we create new functions. Or we can put functions as arguments to other functions. So for example, here I've got x equals math.sign, which is a function. And you saw previously we just sent it a variable with a number assigned to it. Well, we can actually put in there something that it needs to evaluate, and here, for example, we've got degrees divided by 360 times 2 pi. We're taking various different types of blocks of code and combining them all into one command. We can even do the same thing with function calls. So if I want to say I want to take the exponent of a logarithm, I can take the math.log and send it as an argument to math.exp. There are no issues with any of that. As programmers, we can also create our own functions to do whatever we need it to do. In order to do that, we need to do a function definition, and that's going to specify the name of the new function and the sequence of statements that run once we call that function. Here we have an example of how we create our own function. The first thing we have to put is a header, and the header is going to have the keyword def and a space, and then we have the name of whatever we're putting as the function. And then we have parentheses. Within the parentheses is going to be any arguments or parameters that we're sending to that function. All of the statements that follow is considered the body of the function. So we have the two specific parts, the header and the body. Some things to note. In the header needs to end with a colon at the end. And because Python does not ignore white space, all of the body needs to have the same indentation in order to tell Python that it is still a part of that function. The next line that is not part of the function will not have that indentation, and that's how Python knows that we're no longer in that function definition. We have a great example here about how a double quote and a single quote actually do the same thing in Python. But here on this first line, I actually need to use the apostrophe for the word I'm. So if we need to use the single quote in our sentence as an apostrophe, we need to use the double quote on the outside. If you're not using the apostrophe, it doesn't matter whether you use a single or a double. Now in shell mode, if you want to define a function in that shell mode and not in the scripting mode, Python is going to change your prompt from the greater than signs to 3 dots to indicate that it is expecting function statements. So at the regular Python prompt, we're going to type in def space and then our title, our parentheses, and then our colon. Once we hit the enter, Python is going to change that prompt to the 3 dots like we see here. As long as you have those 3 dots, you are typing statements for that given function. In order to get out of that typing of the function, you just put an empty line and it will go back to the 3 greater than signs. A function object is created when the definition is executed, but it's not really going to run anything until it's called. And that function object actually has a type called function. You can actually nest functions and put functions within other functions. So here is an example. I have a print lyrics and then I have a repeat lyrics. So my repeat lyrics function is calling print lyrics twice. And then I can call repeat lyrics. The thing that you have to be aware of is that in Python, you do need to define your functions in order. So I need to define print lyrics first before I use print lyrics. This is a little bit backwards to what we did in C and C++. When I look at this, how many functions do we have defined here? We have 2 defined. We've got print lyrics and repeat lyrics. But when are the print statements actually run? The print statements are actually run once I call repeat lyrics and then repeat lyrics calls the print lyrics. So you must create a function before you call it. In Python, we have something called a flow of execution. The flow of execution is the order in which statements need to run in. Typically, we start with the first statement and we go in order line by line from top to bottom. Functions, on the other hand, are not going to actually run until we call them, so it's a bit of a detour on our flow of execution. When we read code, it's best to follow the flow of execution and not just stick to that strict rule of starting with the first statement and reading them in order until you get to the bottom. Parameters and arguments are actually 2 different things, even though we do use the words interchangeably. I do want you to realize they are different. Arguments are what is passed as a value into a function, whereas the parameter is the variable assigned to that argument. Slight difference in definition. So You're going to assign the argument to a parameter. In our case here, we've got a parameter named Bruce. The value is considered the argument. In this example at the bottom, I actually have some statements being used as my arguments. So here I'm going to call print twice, but I'm sending it the string spam times 4. The same thing happens down here at the bottom, print twice. I'm sending it another function, math.cosine, in which I'm sending math.pi. The argument is going to be evaluated first and then the function call. So, for example, here on the first line, the spam times 4 is going to be evaluated first as spam, 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 and then those 4 spams are going to be sent to the print twice, and that line's printed twice. The same thing with the math cosine and math pi. This argument is evaluated first, and then that result is sent to the function. Here I can also use a variable as an argument. I've got the variable Michael is sent to the value Eric, the half a b, and I can actually say print twice and send it the variable. So in this case, my argument is a variable. Variables and parameters that are used and changed within a function stay within that function. So especially variables created in any function only exist in that function. Once the function is exited, that variable no longer exists. We call this a local variable. So for example, I've got a definition of a function cat twice, and I create the variable cat, which is equal to part 1 plus part 2. Once I leave this cat twice, the word cat and the variable cat don't exist. So here I've got line 1, I've got a line 2, and I call cat twice, and it's just going to print the value of cat. But if I were to type the word cat here, it would give me an error message. For lack of some better terms, our author creates a term called a fruitful function versus a void function. This is sort of common, and a fruitful function has a return value and a void does not. So a fruitful function does some statements and has a result that is then passed back to the calling function. A void function is going to perform actions but doesn't return anything. So here, for example, I've got x equals math.cosine radians. That is a fruitful. It is going to give me back a value of the cosine of whatever angle I sent it. Same thing with math square root. Now here, if I have that same function we were just looking at, print twice, if you remember, it prints a value, but it doesn't actually return anything. So here, if I try to store that into a variable called result, my result is going to be nothing because it doesn't actually return anything. But it is going to print my Bing twice. So in the end, why do we use functions? Well, we can create new functions and give it a name, making a program easier to read and to debug. Those names that we give these functions usually describe what the function does. And it will take that group of statements and give it a name, a title, whatever you want to call it. Makes it a little easier in the end. Functions can also make your programs smaller by eliminating repetitive code. If you take repetitive code and make it a function, then you just call the function each time you need to repeat those number of steps. We can also divide a long program into functions, allowing us to debug each of the functions and these parts before assembling all these parts back together, creating a final program. Finally, well-designed functions we can often reuse. So we can create modules of our own that have functions that we like to use over and over again. Once a function is written and it works and we've debugged it, we can use it as many times as we need. Here comes our debugging word again. Now, it is one of the most important skills for any programmer. Frustrating, yes, but it can also be challenging and interesting, and I don't know, sometimes I think it can be fun. A great way to look at debugging is something called debug by bisection. And this is going to break up your code into smaller chunks, whether they be functions or lines, ensuring that our code is robust and it's stable and we don't ever have to worry that we have an error in that section before we move on. So for say example, we've got 100 lines of code. It's much easier to debug it 4 different times in groups of 20, 25 lines of code than it is to debug 100 lines of code all at once. Appendix A of our book, Think Python, has a lot of great information about debugging, so I do suggest you go ahead and at least skim through it if you don't read it completely. Now let's hop back into chapter 7 and finish up our iterations with just a few topics that we didn't finish last time. We do have a break statement in Python, which is a way to end a loop, and we're in essence jumping out of that loop. So here, while true, which is not a very good programming practice, but you can do it, if the line equals done, we're going to break out of the while loop, or we're going to jump out and print the word done. Here I've got not done, done. It's just a way that if you are within a loop, it's a very easy, quick, and understanding way of getting out of that. Finally, we're going to finish up with a quick chat regarding algorithms. So an algorithm is a mechanical process for solving a set of problems. For example, the square root of a number. It is very mathematical. It is very, you know the steps to do it. There are rules. A calculator can do it. Algorithms are going to be able to work on their own. They don't need any outside intelligence in order to execute. Each step follows a simple set of rules. So think, for example, the addition algorithm. If we have 2 plus 5, you're going to count up from 5 2 times and get 7. There's not really any outside forces that need to be at work in order to do that addition. In all, we've covered chapter 3, which is functions, which there was a lot about different functions. We slightly discussed Appendix A, but I do want you to go and at least skim it. And then we finished up chapter 7 talking about breaks and how we use square roots as algorithms. Join me next time for the next lecture, which we're going to get a little bit more into our Python coding.